So, tell us a little bit about hydrogen engines and how do you break hydrogen? Like, what's the process, and is it really that efficient or not?
Well, there's a handful of different methodologies of creating hydrogen. One is that has some popularity to it is through electrolysis, and that's where you put a little bit of let's call it salt into a water, and think of a battery working in reverse, where you put power in the two terminals and you have gases come out, and those gases are going to be represented as hydrogen and oxygen. And that's how a lot of the electrolysis systems work. So that's one methodology. Another one is through steam methane reforming, where you take natural gas and use, excuse me, use part of the natural gas to create heat. Then the other part is you're going to separate the some of the additional hydrogen that's in the water through a transformation where you break in the covalent bond between hydrogen and oxygen.
So, to
And
stop you real quick, what is a covalent bond?
that's the electrical bond. We'll call it the electrical bond for people who don't understand, but it holds oxygen and hydrogen together.
Okay.
So it's a very tough bond to break. Yeah, it's
Yeah.
water is one of the hardest things to break. If it was easy, all of our vehicles would be running on water instead of gasoline. Gasoline has a much simpler covalent bond which we can break apart, and we can convert that into chemical energy and makes the car go down the street. To try to do the same thing with natural gas and then separate it into oxygen and nitrogen, or oxygen hydrogen, is a lot more challenging. And that was how I got started in the plasma side of the industry. Was that we were taking pipeline natural gas, which sometimes had sulfur contamination and other components in it. We would run the natural gas along with a little bit of oxygen through it to create a process called partial oxidation. And partial oxidation implies that we're going to have just enough oxygen to bond one oxygen molecule with one carbon molecule, which CO is what that would be. So we would end up with CH4 and oxygen, and we would come out with what they call synthesis gas, which is hydrogen and carbon monoxide. And that's what solid oxide fuel cells run on. And so it was harder to do process than it sounds. Plasma was a precursor to making the whole system work. What it would basically do is it would set up the heavy lifting work to be done with a specialized catalyst after.
So it would loosen it up a bit.
Yeah, so in the catalyst, it would allow the catalyst to run at a much more fuel-rich environment for that partial oxidation. If you tried to run a partial oxidation process without pre-treating the gas with plasma, it would shut down in a relatively short period of time. They couldn't sustain it. So the plasma would do that.
Now, you dealt with getting rid of or helping out with tailpipes, right? Is that part of one of the projects you did?
Yeah, so after we spun off the technology to make syngas, the focus was on trying to use different types of plasma to clean up tailpipe emissions. And basically what we're looking at is hydrocarbon emissions, which is unburnt fuel. Well, that's pretty easy to resolve in the engine. You can just run a little bit leaner and that gets rid of it. The problem is when you run an engine a little bit leaner, it typically makes higher amounts of NOx emissions. So
you're talking about nitrous oxide, not nitric oxide.
Yeah, so I was working with some colleagues out in Oregon on that back in, I think it was 17, 18. And we were making halfway decent progress with it, but it was a technology that I didn't see coming to any type of conclusion in the near future. The problem you have with tailpipe emissions, especially on motor vehicles going down the highway, is that you have what they call transient operation. And the transient operation implies that you have constant loading and unloading of the throttle to go up a hill, down a hill, pulling a load, stop-start operation. It's always different, and you're always trying to make on the second changes in the loaded of and what you're trying to do with plasma, and plasma systems are just not ready for that type of emissions control work. So along the line, I was working with a bunch of guys out in, like I said, in Oregon. They were all farmers, and I really knew at that point there that I knew I could make small amounts of nitrogen compounds, which would be nitrite and nitrate primarily. And they said, hey, can we use some of that water on our farm? So I started experimenting with it out there. This might have been around 17 or 18. And they came back with me and stuff works really, really well. So I started putting more and more focus on it. And by the time we met, I had left that company, and I was really trying to make a push to get something out there into the forefront of everybody. So after I left the group in Oregon, we had put together some development projects working with the USDA in Fort Pierce, Florida, and right next door to them is a University of Florida facility in one of their ag centers. And we started to make some really good progress in using that water that contained, at that point there, it was relatively low amounts of nitrogen oxides, but we were seeing really good results. And this was all primarily on citrus, juvenile citrus trees that were inside of a lab, but they were all severely infected with citrus greening, or HLB, which has a long name, but it's about that long.
Yeah.
And the idea there was that we didn't think we would ever cure the disease, but we would make it irrelevant. And how we end up doing that, we started to see good progress, and then all of a sudden COVID came along, and everything came to a grinding halt. All of the government entities and universities, they all shut down operation.
Yep.
So I talked to a guy I was working with at the USDA in Fort Pierce, and I'd met this gal along the way that worked with you, and we talked about doing something. And so I go back to the guy at the USDA. I say, hey, what do you think about applying this foliar instead of putting it into the soil? He goes, I think it's a really good idea. So I went shortly thereafter. We made it out to a 5-acre orange grove in DeLand, Florida. I had a backpack sprayer on, and I had water that was diluted at that point about 4 or 5 to 1. And I'm spraying citrus trees in there. We got pictures of before, we got pictures of after. We have Brix reading, and we have a handful of other matrices that my coworker who was doing this with me took the time to measure. And over a relatively short period of time, you could see a significant difference in leaf coloration and the health and vigor of the trees coming back from, they had been basically pummeled by this disease for some of them 10 years or more.
That's horrible, yeah.
And the farmer was actually going to mow them over. Well, some of these trees that he was going to mow over, we actually got to produce fruit. And he was absolutely dumbfounded that he thought they were done for. So what we learned there was that by applying the nitrogen water, or plasma activated water, directly to the canopy, that the uptake efficiency far exceeded what we were putting into the ground, because what we were putting in the ground, at least on the citrus trees, was restricted at getting to the canopy because the phloem in the plant, or the arteries of the plant that transfer nutrients from the ground to the canopy, was keeping that from being a reality. So,
yep.
And along the line, I guess the person I was working with knew you and said, hey, you got to talk to this guy, Travis. And here we are, 5 years later, 6 years later.
Pretty amazing. So